Hi everyone, welcome back to our channel. So today we are going to solve this problem number 26. The given problem is find the current through 1 ohm resistor in the given electrical network using Norton's theorem. Okay, here the confusing concept is two types of sources are given. So this problem is under two types of sources. First source is independent source. 12 volts is an independent source, and this source is a current dependent current source. Current dependent current source. Why current dependent means this is I naught, therefore I naught is called three times current dependent. What kind of source? Direction is given, current dependent current source. So when you have the independent source and dependent source, the procedure of finding is, first we need to find out open circuit voltage, and second we need to find out ISC, and then by using these three data we have to find out R Nortons or R Thevenin is equal to VOC by ISC, and then you try to construct the equivalent Norton's circuit. Then we can find out IL from it. Now let us try to see how to solve. So in the first step, I'm going to find out VOC. Okay. So first step is finding open circuit voltage. How to find this open circuit voltages? So first, this is the load. First, remove the load. Okay. So if you remove the load, the network is like this. So when you remove the load, then automatically RL is removed, then automatically current becomes 0, and the voltage across this open circuit we are going to call it as open circuit voltage, and this is of 3 ohm, and the direction of current in this branch is 3 into I naught. Already in the problem the current I naught is given like this, and this is of 6 ohm, and this is of 12 volts. Okay, so now the voltage at this point or this point is same, which is nothing but VOC. Okay, so now let's try to find it. Okay, already you can see here in this branch, already you can see here in this branch this current is flowing. Okay, and in this branch a current is given, and we need to write down the current in this branch. I'm writing this current as some I1. Okay, so now in order to link all these currents, let us try to apply Kirchhoff's current law at node VOC. At this node I am applying at the node VOC. So where this method is called nodal analysis. Okay, so to identify the entering currents, already as per the given problem, the current in this branch is nothing but how much I naught current is flowing, plus the current in this branch is how much 3 into I naught is the current in this branch, and I want to write down the current in this branch. Both are entering and this current is leaving. I am writing this current as I1. So therefore I naught, this can be written as 4 I naught is equal to, so I want to write down the current which is flowing in this branch. How to write down the current? V by R. The formula for current, since we have the formula for current I is equal to V by R. Okay, so how to write down this current is, so the voltage at this point is positive, the current is leaving, therefore I can write down this as VOC minus 0 divided by, what is the resistance of the branch? 3. So, okay, so here we are trying to do, we require VOC as the first step, but the this we can write down it as 4 into 3 is nothing but 12 I naught is equal to VOC. I need to find this I naught. Okay, so how to write down I naught? You see the current I naught flowing from this point to this point. Okay, so current is leaving, what is the leaving terminal of the voltage? 12 volts, and it reaches this point. Whenever it reaches this point, so then how to write down I naught? So 12, this is a positive VOC, and this is minus. Okay, this is plus 12, and the leaving terminal of voltage is 12 minus C divided by 6 ohm. Okay, so substitute this in this problem. Okay, So that is equal to 12 into 12 minus VOC divided by 6 is equal to VOC. If you simplify it, 12 ones are 12 twos are. Okay. So when you perform the multiplication, then you are going to get, so VOC is equal to, you are going to get it as 8 volts. First step we have find VOC, and in the second step I need to find out ISC, short circuit current. The meaning of short circuit is we have to remove this load resistor and short circuit those two terminals. Okay, so when you perform it, then you can see here the network is like this. So a small branch, so this is of 12 volts, and here we are having, and these two ends we need to short circuit, and the current in this branch is I short circuit, and this is of 3 ohm, and this is of 3 into I naught, and the current in this branch is I naught. So you can see here, show short circuit parallel to an resistor. Okay, if we find out R equivalent between these two ends. Okay, so between 0 and this 1, if you mark, and if you write down between 1 and 0, so R equivalent is equal to, you can see here these two branches are connected in parallel. Okay, so whenever these two branches are connected in parallel, so these two branches are connected in parallel, R equivalent is equal to, so this is having R is equal to 0 and this is of 3, so R equivalent is equal to product of resistance 3 into 0 divided by 3 plus 0, since numerator is 0 and R equivalent is equal to 0. Now this branch is also R equivalent is equal to 0, and how much current flows is I short circuit current, and replace the same node. Okay, so from the first node we have one more voltage source. This is the current dependent current source, and with one branch and with an voltage of 12 volts and a current of I naught with a resistance of 6 ohm. Okay, so now we need to link all this. So nothing to link, is very simple as per the given problem. So the current in this branch is already known, the current in this branch is already known, and current in this branch is also known. So let's try to assume this as the node. So when you short circuit here, the voltage across this point is 0. Okay. So now directly I'm going to apply nodal analysis at this point. Apply nodal analysis. There's nothing but apply KCL at node V. So you see the currents what are entering. So first current entering, this is the red color branch. So I naught is entering, and another current which is entering is 3 into I naught is entering, and the leaving current is ISC. So this branch is entering, and this branch is also entering the node, and this branch is only leaving. The current name is ISC. We require ISC, so we can link this 3, which is nothing but 4 I naught is equal to ISC. So now we require the value of I naught. So how to write down I naught? You can see in this problem. So I naught I can write down, the current is flowing in this direction. Okay. So this is shorted and the current is flowing, and whenever it is flowing, this is nothing but plus 12, and what is the voltage at this point? 0. 12 minus 0 divided by, okay, R. What is the R value? 6. 6 ones are 6 twos are, so I naught is equal to 2. So this is nothing but 4 into 2 is equal to ISC value. So therefore ISC is equal to how much? 8 amperes. So successfully we have been find the second step. uh, VOC is of 8 volts, ISC is of 8 ampere. Therefore R Nortons is equal to VOC. VOC is 8 and I short circuit is also 8. Therefore you are going to get it as 1 ohm is the Norton's equivalent values. Okay. now let's try to substitute all those value. So now the resultant Nortons equivalent circuit is like this. So you have an current source. So the current source value is 8 ampere, and you have a shunt value where the name of this resistor is R Norton. So R Nortons is equal to how much? 1 ohm. And in the question itself, the load resistance is given. So this is the load resistor where IL we need to find out, where the given value of resistance is how much? 1 ohm. Okay. So this RL given is how much? 1 ohm. This RL is equal to 1 ohm. Now use the current division rule, or to find out the current across which branch. 1 ohm is equal to total current. What is the total current? 8 amperes into. So in this branch I require the current. The branch in parallel to this branch is nothing but 1 into 1 divided by the sum of resistors which are connected in parallel. So what is the sum which two are connected? 1 plus 1, which is nothing but 8 by 2 is equal to 4 amperes is the problem. So I would like to recall the problem. Why? Because these are very important problem in gate point of view while you are solving. So when you see this problem, see here initially an independent source is given and dependent source is given. When both are acting, this is an independent source and this is a current dependent current source. So first we need to find out VOC. So I will remove the load and I will mark the voltage VOC. To find out this VOC, I applied KCL and I linked I naught current 3 I naught and VOC. So there also I am getting some I naught. I had written it as 12 minus VOC by 6. So I solved it. And similarly, I have been removed the load resistor and short circuited it. Short circuit parallel to a resistor is once again short circuit. Automatically, if you apply the nodal analysis at this point, the voltage at this point, okay. So the voltage at this point is 0. So how to write down this I naught? Plus 12. So current is leaving plus 12, and somewhere it is leaving plus 12 minus 0 divided by 2, which is nothing but 2 amperes. So apply the nodal analysis, then you will get the current. Then substitute all in the Norton's equivalent circuit. So this is ISC current, Norton's current, and the load resistor. Then you can find out the current. So these are very important problems in exam point of view, in external exam point of view, and competitive exams point of view. Hope you are able to understand. So if you feel the explanation what I am giving are you able to understand, please like the video, and those who are studying the same subject, please share to your friends. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. So kindly support this type of free channels for the development of students as well as for the faculty. Viewers obediently, Ram will meet in the next video. Thank you for watching.